Hi guys, this is Dr. Chris Bunn from the Atlas Clinic in South Ogden. I've been wanting to make this video for a little while, but I want to show you the marking procedures that we use on our cone beam CT analysis here in the office. So I'm just going to jump over to this real quick and let's talk about it for a second. So on this view right here, this is where we would get the 3D image. The computer I'm recording this on has a really slow old graphics card, so that's why we don't see that. So we start with the sagittal view. What I'm going to try to find here is the Atlas sagittal plane line. So I want to make sure that when we're analyzing the Atlas, that we have the correct plane. We've taken this X-ray to the correct plane. In the Atlas orthogonal technique, this is a really tough film to take because you have to make sure that you're taking it through the top of the skull and that you get everything parallel here. But in the world of CT, it's really simple to grab that view. You can see over here on the side what happens as we begin to flatten out and pan out. And this guy's got quite a pronounced forward head posture, and that's coming quite forward here. You can see it kind of compresses the airway right there. Obviously not ideal. So start on the sagittal. We basically draw the Atlas sagittal plane line in there so that we know that we're shooting and we're viewing this at the right angle. Next thing I'm going to look for as we do our analysis here, so we're going to take a look at the TMJ joints. And obviously you want to see that there's more space than this at a TMJ joint. That one's really jammed on this left side. So that's going to cause any number of problems and symptoms that we treat here in the office: dizziness, vertigo, ringing the ears, whatnot. So I want to find the sagittal suture lines, or the squamous suture lines, and there's one there, and there's one there. So I'm getting 140 millimeters across. I'm going to divide that by 2. We're going to hit 70, and then we're going to drop a plumb line off of that straight down. And I always like to do this before we actually visualize the cervical spine, just so I can get an honest measurement. So you see, we would like, in a perfect world, for this plumb line to hit right there at the tip of the dens. And you can see with him, it's not at all. The next line I'm going to find is the Atlas frontal plane line. And on this, I would be open to anybody's suggestions, but I'm using the transverse process where it connects into the body of the Atlas right there. So there's my landmarks, and I'm going to come bring it across, and you can see this is quite a good tilt there on the Atlas. So we've got an ACD cephalic displacement on the left here. Next thing I'm going to do is I'm going to head down to the horizontal view, and we are going to find, I'm going to scroll up right here, and we're going to find the center of the foramen magnum. Now, how I do this like this? We come across here. We're going to measure at the widest point. So we're getting 36 millimeters. I'm going to call that 35. We'll call it 35 and a half. Now let's call it 30. That's closer to 35. So 17 and a half is the center. Okay, so 17.5, boom. So now what I'm going to do is I'm going to draw a measurement line right in the center of the foramen magnum. And I'll erase that guideline right there. And as we start to move down, I always like to make this one white. As we begin to move down on top of Atlas, we'll scroll down here. And we want to see rotation, get our rotation measurement at the Atlas. And we see that we're looking for the condyles, and there's one. They look like little peanuts, so I'm going to find the base of the condyle. And if it's blurry, or if I have a question or a problem with it, I'm using the transverse, the vertebral foramen kind of as a backup. I always like to make the Atlas one blue. And then we'll find our axis spinous process. I'm going to come down here. Oh my goodness, and he is well rotated there. I'll bring that up and make it parallel. And I always like to make the axis one red. So This is our basic